Hello everyone and welcome back. In this new section of the course, and before introducing any state management techniques in our application, let's talk about component communication. So far here in our application, we had multiple components interact with each other via the Angular input syntax. So for example, the courses card list component, which is a purely presentational component, is receiving here the courses that it needs to display via an Angular input member variable. Now let's think about what would happen if we would have two Angular components at completely different levels of the Angular component tree that still need to interact with each other. Clearly, in that situation, we cannot use standard Angular inputs and outputs, because this mechanism is only useful when one component is present on the template of another component. So if the two components have a child-parent direct relationship. However, if that would not be the case, then how could two components interact with each other in a maintainable way if they were present at completely different levels of the component tree? You might be thinking that this situation is rather rare, but in fact it's going to be present in almost every Angular application that you build. Let's give a couple of examples of commonly needed components that you are for sure going to need in your own application. So the first example is the one of a loading indicator. So whenever we load the data from our application due to the delay on our backend, we want to show to the user some visual feedback with the loading indicator saying that the data is still getting loaded. And especially here in our save course operation, which takes a couple of seconds to execute in our backend, we want to be able to show here a loading indicator on top of this edit course dialog screen in order to give some feedback to the user that a save is ongoing. So the loading indicator will be present at a completely different level of the component tree than the home component or than the edit course dialog. We want to be able to make sure that the loading indicator, which is going to be a separate Angular component, and the different components that need to interact with it, such as the home component or the edit course dialog, are not tightly coupled to each other. We want to be able to make sure that the two components can interact in a maintainable way. In the next few lessons, we are going to learn how, by adopting a reactive design, we are going to be able to have components interact with each other in a decoupled way, even though they are at very different levels of the component tree. So the first example that we're going to be providing is a loading indicator. Another very common example will be an error messages panel that is going to be displayed here, and that will allow us to display errors that are triggered in many other places of the application, such as, for example, the home component whenever we are loading the courses, or the edit course dialog whenever we are trying to save our course in our backend and something goes wrong. We need somehow to show an error message to the user, and for that we are going to be using a messages panel that will also interact with the rest of the application using a reactive design. So let's now start with the first example, the loading indicator. In order to build our loading indicator, we already have here the skeleton of a loading component. Let's have a look at the initial version of our loading component. So as you can see, we simply have here an empty component. It's just the skeleton of the component. No logic was added yet. The HTML template is currently empty, and we also have here a little bit of CSS that we're going to need to implement our component. Based on this initial starting point, let's now discuss the design of the solution that we're about to adopt. Let's learn how using a reactive design is going to make it really simple for multiple parts of the application to interact with the loading component in a transparent way. Hello everyone and welcome back. In this lesson we're going to start the implementation of our loading indicator solution. As we will see, by adopting a reactive design, we are going to make it very simple for different components at different levels of the Angular component tree to easily interact with the loading component in a decoupled way. Let's start at the beginning. Let's first define here some HTML for our component. We are going to be defining here the loading indicator component by using the Angular material spinner component. And we are going to be wrapping this component into a container to which we are going to be adding some styles of our own. Let's then define here a div. We are going to be adding it a CSS class that we are going to be calling spinner container. So the spinner container class is already available here in our loading component.css file. And as we can see, these styles that we are applying here are going to give to the loading indicator a background with a gray color that is going to occupy the whole screen. And the loading indicator itself is going to be a spinning wheel that we're going to see here on the center of the screen. Let's then go back here to our template. We're going to take the material spinner and we are going to place it inside our gray background container. Let's now discuss how this loading indicator is going to be used in our application. So as you can see, this has a selector named loading. So with the loading tag, we can add this loading indicator anywhere on the application, but in practice, we're going to be adding only one instance of this component and we're going to add it here at the level of our application root component. So if we open our root component, we're going to see that here we have the material top menu that we see here linked to this hamburger menu. And we also have here the main router outlet of our application. So this is where top level components such as, for example, the home component or the course component are going to be displayed here in the middle of the screen, just below our material side menu. Now the loading indicator instance that we're going to add to our application is going to sit here just on top of the router outlet. If any component on the application needs to display briefly the loading indicator, that component, such as for example the home component or the edit course dialog component, needs to somehow send a message to the loading indicator component and inform it that the loading indicator should be displayed. Otherwise, in general, the loading indicator should be hidden. Now the question is, because this loading indicator is here at the level of the application root component, we can now ask ourselves, how will the home component, which sits at a completely different level of the Angular component tree, how will the home component, whenever it's loading a list of courses from the backend, be able to notify the loading component that is in a completely different part of the application that the loading indicator should be displayed, or that it should be hidden because the loading of the courses is already completed. The way that these two components at very different levels of the component tree can easily interact with each other is via using a shared service that we're going to be calling the loading service. Let's now define the API of this service. Let's start first by creating here a new file, loading.service.ts, that we're going to create here inside the loading folder. Inside it, we're going to be defining here a new class. We're going to call it loading service. We're going to make this an Angular service by adding it the injectable decorator, but let's leave the injectable decorator with its default configuration. So unlike, for example, here the courses service, we won't be defining the provided in property and we won't be setting it to root either. So this is used in the case that we want to make the service a global singleton, meaning that there is only one instance of the service on the whole application. That will not be the case, however, of the loading service. The loading service might potentially have multiple instances in our application. We might want to use a loading indicator, for example, locally at the level of a form in our page to indicate that some operation is taking place on the background, but we might not want to block the whole user interface with a global loading indicator, like when, for example, we are loading courses from the backend. We might have the need in our application for small loading indicators that are local to a given component. Because we have not defined here the provided in property in our injectable decorator, we now need to define where this service is going to be available in our dependency injection tree. So going back here to our application component, we're going to be adding here on the providers of this component an instance of the loading service. This means that this instance of the loading service is going to be visible only to the application component and to its child components. Now let's talk about how will this loading service enable the communication between the loading component and other parts of the application that want to display a loading indicator. Well, the loading service is going to get injected both on the loading component and into any other components that need to show a loading indicator. Let's start by injecting the loading service here. We are going to define here a member variable that we're going to call loading service, and we are going to apply it the type loading service. Now let's go to another place on the application that has the need of displaying a loading indicator to the user. One such example is going to be, for example, the home component. The home component is responsible for fetching the list of courses from the backend. So here we want to be able to show a loading indicator to the user while the loading takes place. For that, we have injected here the loading service. Now, another component in our application that needs a loading indicator is the edit course dialog that we see here on the screen. Let's open this new component. We are going to be using Command-Shift-O, and let's look here for our course dialog component. Here in our constructor, we are going to be injecting here also the loading service. As we can see, using the Angular dependency injection mechanism, which allows us to inject any dependencies that a component needs directly in the constructor without knowing where the dependencies come from. Using this mechanism, we can very easily inject a shared service at different levels of the component tree. Let's now talk about the design of the loading service. The loading service, as we will see, is going to be adopting a reactive design, and this is going to make it very simple for components at different levels of the component tree to be able to interact with each other in a decoupled and maintainable way. Hello everyone and welcome back. In this new lesson, we're going to talk about the reactive design of our loading service, and we're going to start its implementation. So what we want to do with this shared service, which is getting injected here in the home component, also on the course dialog, and anywhere else in our application where we need to show a loading indicator, we want to provide via this service a convenient way for different parts of the application to trigger the display of the loading indicator without any of the multiple parts of the application, such as the home component, etc., to be directly aware of the existence of the loading component. So the loading component, it's this simple component that we have defined here with the material spinner that we are injecting in our application in only one place for the moment. We are injecting it here at the level of our application root component, just above our main router outlet. Now, the loading service is also getting injected here in our loading component. So this is how our loading component is going to interact with the rest of the application via the loading service. Let's now define then the public API of the loading service. The most important part of this public API is going to be one observable that we're going to be calling the loading observable. This observable is going to be of type observable of Boolean. So this means that the values emitted by this observable are either true or false. This observable is going to emit true whenever we want to show the loading indicator to the user, and it's going to emit false if we want to hide the loading indicator from the user. Let's now see how the loading component is going to consume this observable. Going back here to our loading component, we are going to be making this loading service not a private property, but we are going to make it public so that it's accessible also by the template of the component. And here in our component template, we are going to consume the loading observable using the async pipe. And we want to show to the user the whole loading component if the observable emits true. Let's then apply here the ngIf Angular directive. Let's access the loading service and let's access the loading observable. We're going to be applying here, just like before, the Angular async pipe that is going to take care of subscribing to the loading observable, and it's going to be in charge of passing the emitted values by the loading observable to the template. So this expression here is going to be evaluated to true whenever the loading observable emits a true value, and it's going to be evaluated to false whenever the loading observable emits a false value. Depending on if the value of this expression is true or false, then the material loading indicator with its gray background is going to be shown to the user or not. Now let's talk about the advantages of this simple design. So by using an observable and consuming it here in our template, this means that the loading component is completely unaware of how the rest of the Angular application is structured. And namely, the loading component is not aware of the home component, and it's not aware of the edit course component or of any other component of the application that needs to show a loading indicator. The loading component simply knows about the loading observable of the shared loading service, and that's its only means of interaction with the rest of the application. Now, the rest of the application, besides the loading indicator, can also consume here the public loading observable in order to get an indication if the application is loading something from the backend or not. But more often, what the rest of the application wants to do is to simply turn on or off the loading indicator. So here at our loading service, we're going to be adding to its public API a couple of methods. We're going to call it loading on and loading off. And this is going to enable us to turn on and off the loading indicator at any moment from anywhere in our application. Although it's convenient to have these two methods available here in case that we want to explicitly turn on or off the loading indicator by any reason, more often than not, what we want to do is to turn on and off the loading indicator in our application in a way that is linked to the life cycle of a given observable. For example, we want to be able to turn on the loading indicator whenever we create a load courses observable, and we want to turn it off when the observable either completes or errors out. So in order to make it simple for components such as the home component to turn on and off the loading indicator depending on the life cycle of a given observable, we are going to be adding here a new method that we're going to be calling showLoaderUntilCompleted. This is going to take as input argument an observable, which is the observable that we want to track the life cycle in order to decide if the load indicator should be used or not. And we are going to be returning as the output of this method another observable of the same type, and that observable that we are returning here is going to have loading indicator capabilities. So this new observable is going to be able to turn off and on the loading indicator at the appropriate moments. Now, this method should be compatible for observables of any type, so let's make this a generic type by adding here a generic type argument to our function. So with this, we will be able to have type safe code with any type of observable. Let's, for the moment, in order to fix this compilation error, just return here undefined as a default implementation of this method. We are going to see exactly how we are going to be implementing this method later on in this course. Right now, in the next lesson, we're going to talk about how to implement the loading on and off method, and also how are we going to create the loading observable that we see here. So as you can see, so far we have just defined the loading observable, but we have not yet assigned it any value. Let's then learn how we are going to implement the loading observable, which is the most important part of our reactive design. Hello everyone and welcome back. In this lesson we're going to continue the implementation of our loading service. Let's remember that this is a shared service that enables components such as the course dialog component or the home component that we see here on the screen to be able to turn on or off a loading indicator that might be placed at a completely different level of the Angular component tree where, for example, the home component is situated. In our case, we have here a loading component that is placed here at the level of our top router outlet that needs to be turned on and off by various different components of the application in a maintainable way using this shared loading service. So the key component of our design is the loading observable, which emits observables of type Boolean. So true if the loading indicator should be shown and false if it should be hidden. Now the question is, how are we going to define this loading observable? Well, the key ingredient for defining custom observables in any application in general is RxJs subjects. So a subject is very similar to an observable in the sense that we can subscribe to a subject just like we subscribe to an observable, but the subject has the extra capability of emitting values. So with an observable, we only have a subscribe method, but we have no way to control the values emitted by the observable. That is not the case with a subject. With a subject, we can define exactly when this observable here can emit the values true or false. Let's then define here a new RxJS subject. We are going to be calling it the loading subject. And we could be tempted, for example, to use the RxJS default subject class. However, in general, I think it's better to use the behavior subject class. The behavior subject class is a special type of subject that remembers the last value emitted by the subject. So any new subscribers are going to receive the last value or the initial value in case that no value was emitted yet. This is better in general for asynchronous applications because we don't know the exact timings of the life cycle of each component. We want to make sure that any component that needs a value emitted by the loading observable to be able to receive at least the last value emitted, even if the subscription only happens after the value was emitted. So we're going to be defining here the parametric type of the values emitted by this subject, which are going to be booleans just like the loading observable. And in the case of the behavior subject, we also need to provide here an initial value for this subject, which is going to be the value false. So by default, at the beginning of our application, the loading indicator should not be displayed. So we are going to be emitting initially this value of false. Now let's see how we're going to create the loading observable from the loading subject. If we have a look here at the API of the loading subject, for example, using here the loading on method, we're going to see that the loading subject also provides a subscribe method. So in that sense, it's very similar to an observable. However, we would not want to have other parts of the application to access directly the loading subject. So that's why we have made it private. We want to make sure that the loading subject is private because not only can other parts of the application subscribe to it if it would be public, but the loading subject also provides us with the ability of emitting new values. So we have here a next operator that allows us to emit new values for our subject. So if other parts of the application would subscribe directly to the subject, they would also be tempted to use the next method in order to emit new values. And we want to avoid that. We want to clearly separate the ability from subscribing to new values from the capability of emitting new values. The idea is that anyone outside of the loading service should be able to subscribe to the loading observable and receive new values, knowing if the loading indicator should be displayed or not. However, only the loading service should have control over the ability of emitting the values. So that's why instead of exposing the subject directly to the outside of the loading service, we are going to instead take the loading subject and call here the asObservable method. This is going to derive an observable from the subject that emits the exact same values as the subject, but it's simply an observable. So the loading observable will not allow us to control what values are emitted. With the loading observable, we will only be able to subscribe to it and get notified when new values are available, while keeping the ability of emitting new observable values inside the loading service only. Using the loading subject, we can now implement very easily the loading on method. We are going to be accessing here the loading subject, and we are going to emit a new value, which is going to be the value true. In a very similar way, we can implement the loading off method. So now we want to turn off the loading indicator, so we're going to be emitting here the value false. The way that this works is that the values emitted via the subject are also going to get emitted by the loading observable. So whenever a part of the application turns the loading indicator on, this loading observable is going to emit the value true, and whenever another part of the application turns off the loading indicator, the loading observable is going to emit the value false. Now, you might be thinking at this point in the course, if we already have here the ability of turning on and off the loading indicator, isn't that all we need for implementing the loading service? Why do we need this method here? Well, let's try to use these two methods, loading on and loading off, in our home component and understand why this show loader until completed method is going to be very useful. Let's switch here to our home component, and let's notice that we have already injected here the loading service. Now, what we want to do is to use the loading service in order to turn on the loading indicator when we start loading the courses, and we want to turn the loading indicator off whenever the courses are completed. So how do we turn the loading indicator on? We do so by accessing here the loading service and calling the loading on method as expected. And now what we want to do is to turn off the loading indicator whenever this observable here either completes or errors out. So we can do that by using the RxJs finalize operator. This operator is always going to be called when the observable that we are receiving here as input either completes or errors out. So here on finalize, we are going to be accessing the loading service and we are going to turn off the loading indicator. So it's very important to use finalize in order to make sure that we wait for the load all courses observable to complete properly, which is going to be the most common case, but it's also important to handle the case when the service errors out. So if there is an error while loading our courses from the backend, we want to make sure that we don't accidentally leave the loading indicator on, blocking the whole user interface and preventing the user from continuing to use the application. Let's now try out our new loading indicator functionality. So in order to make the loading indicator a bit more visible and for a longer period of time, we're going to artificially increase the time that this load all courses request takes to get processed. So if we open here the load all courses method, we are going to see that we are hitting the /API/courses endpoint of our REST server. Now, if we open here our server folder in our Reactive Angular course repository, we are going to find that the server is a very simple Express server with only a couple of routes defined. Here on the /API/courses route, we're going to get here the get all courses express route. So this is the server code that is getting executed whenever we load our courses. So as we can see, we can artificially increase the time that it takes to load our courses by increasing the value of this set timeout. Let's make this, for example, 1.5 seconds instead of only 200 milliseconds. And let's apply this new delay by going here to our terminal and stopping our REST server and restarting it once again. So now we have a new version of our server running. where the processing of the get all courses route is going to take much longer. Let's then go back here to our home component and let's refresh our application and pay close attention to the presence of a global application loading indicator. We are going to reload the new version of our application, and as we can see, here is the loading indicator as expected. Let's now quickly review our solution and let's focus on its reactive design. So in order to have components such as the home component or the edit course component to interact with the loading indicator component, which sits at a very different level of the Angular component tree, we have used a service in order to enable that interaction. That is the loading service. The loading service has a reactive API in the sense that it exposes a loading observable. This observable emits true if the loading indicator should be shown and false if it should be hidden. Now, we have the loading indicator being public, meaning that any part of the Angular application can be aware if a backend loading operation is ongoing, but only the service itself has the capability of emitting values for this observable. So the observable is derived from a private subject that is used for emitting new values using, for example, loading on or loading off. This same loading service is then going to get injected here in our loading component, and the public loading observable is going to then be consumed here in the loading component template using the async pipe, and it's the values emitted by the loading observable that are going to determine if the material loading indicator should be displayed to the user or not. And with this, we have almost completed the implementation of our loading functionality. In the next lesson, we are going to complete here the implementation of the loading service by implementing the show loader until completed method. This method is going to provide us with a slightly more convenient API for interacting with the loading service. Hello everyone and welcome back. In this new lesson, we're going to finish the implementation of the loading service by providing you with a slightly more convenient API that will help us to turn on and off the loading indicator. So I'm talking about the show loader until completed method. Before implementing it, let's see how this API compares with the direct use of loading on and loading off. So here in our home component, we were turning the loading indicator on at the beginning of reload courses, and we were turning it off whenever this observable here either completes or errors out. Now let's see what this would look like if we would not be using this API. So let's start by removing here loading on, and let's remove here the use of the finalize operator. With this, we now have the original definition of our courses observable, which had no loading indicator capabilities. So how are we going to add back those capabilities using the show loader until completed method? Well, we are going to take this observable that we have defined here, and we are going to call the loading service, and we are going to call the show loader until completed method. Now, this method takes as input argument an observable. We want to pass to this method the observable to which we want to add loading indicator capabilities. So in this case, the courses observable. What we are going to get back here from the show loader until completed method is going to be a new observable that I'm going to call the load courses observable. Now, this observable has loading indicator capabilities, meaning that at the beginning of the observable lifecycle, we are going to be turning on the loading indicator, and when the courses observable either completes or errors out, we are going to turn off the loading indicator. So it's this new observable with loading capabilities that we want to pass on to the rest of the application. Let's then use it here in order to define the beginner and the advanced courses. As we can see, this API is slightly more convenient, it's less invasive, we don't have here new operators such as the finalize operator added here to the definition of our courses observable. So let's now see how can we implement the show loader until completed method. Let's start by removing here this default implementation. Now, the first thing that we want to do here, while the observable that we have received here as an input does not initiate its life cycle, is to create here another initial observable that is going to emit a value. That value is going to be used to trigger the loading indicator. In order to create our initial observable, we are going to use the RxJs factory method of that we are going to add here to our import statement, and we're going to use it to create an observable that is going to emit only one value, which is going to be the value null, and then this observable is going to complete immediately. Now, why is this initial value useful? When we receive this initial value, we are going to use the tap operator that we have introduced before in order to trigger a side effect. That side effect, as you are probably already imagining, will be to trigger the loading indicator. So we're going to call here loading on, and this is going to show the loading indicator to the user. Now, once this initial value gets emitted and the loading indicator is on, now what we want to do is to have this observable that we are creating here, that we are going to return as the output of show loader until completed. We want this observable to now to start emit the values emitted by the input observable. In order to switch from the values emitted by this initial observable and the values emitted by the input observable, I'm going to be using a higher order mapping operator. I'm going to be using, for example, concat map. Concat map is going to take the values emitted by the source observable, in this case this observable here, which only emitted the value null and then it completed immediately, and concat map is going to transform this value into a new observable, which is going to be our input observable. This means that the values emitted by the result observable are going to be identical to the values emitted by the input observable, with the exception that the loading indicator has already been turned on. Now, when this input observable completes or errors out, we're going to be turning off the loading observable. We want to be able to turn off then the loading indicator. So again, we're going to be using here the RxJs finalize operator in order to get notified that our observable has ended its life cycle. And we are going to be calling here the loading off method. And this is going to turn off the loading indicator. There is a lot going on in this simple implementation, so let's review it quickly. We have started here by creating a default observable just in order to be able to create an observable chain. When we receive this initial value, we start by turning on the loading indicator and we switch to outputting the values emitted by the input observable, and we do so using the concat map operator. When the input observable stops emitting any values and completes, we are going to be finalizing also our observable chain, and we are going to be turning the loading indicator off. The main advantage of this design with this off null source observable is that the loading indicator will only be turned on when the resulting observable returned by show loader until completed is subscribed to. This means that the loading indicator is going to be shown or hidden in a way that is completely linked to the life cycle of the returned observable. Only when the returned observable gets subscribed to will the loading indicator become on, and only when the returned observable finishes its life cycle will the loading indicator be turned off. Notice that this method takes here a parametric type t, but we don't even have to specify it explicitly whenever we are calling here show loader until completed. In the case, for example, of our home component, we have simply passed in here the courses observable, which is of type observable of course array, meaning that it emits values which are arrays of courses, and we didn't have to add here the parametric type course array in order to tell to the implementation of show loader until completed that our observable emits arrays of courses. Instead, we can omit this parameter, and the implementation of our method is going to infer the type of the load courses observable. If we use here the shortcut Ctrl+Shift+P, we are going to see that using the TypeScript type inference, this load courses variable is already an observable of course array. This means that the rest of our program is type safe. As we can see, this show loader until completed API is slightly more convenient to use than the previous version that we had here. We don't have to add finalize operators everywhere just to turn off the loading indicator. It's a little bit less verbose, so you have here a more convenient option for adding loading indicator capabilities to your components and services. Let's now see the show loader until completed functionality in action. We're going to reload our application and let's keep an eye here, and as we can see, the loading indicator functionality is working correctly as expected. Let's now see how can we apply this loading indicator functionality in other parts of our application. Hello everyone and welcome back. In this new lesson we are going to continue the implementation of our reactive loading indicator. So far we have been using the loading service and the loading functionality in general only here at the level of our home component. Let's now switch back here to a larger window and see what happens if we try to open our course dialog component that is also receiving here in the constructor an instance of our loading service. The loading service is the shared reactive service that we are using to have multiple components in our application, such as, for example, the course dialog and the home component interact in a decoupled way with the loading indicator component. Let's switch here to a larger window and see what happens if we try to open the edit course dialog. As we can see, our application crashes. You can see here that the dialog was only partially opened, and if we inspect the console in order to understand what's going on, we're going to see that we have a dependency injection error. We have the message no provider for loading service. And this only happens when we try to open the dialog. So going back here to our course dialog component, because it's opened by the Angular Material Framework, exists in a completely different component tree than our home component. So if we see here our home component and we have a look at the home component template, we are going to see that the template is made of a tab panel and a couple of course card lists. And if we open the course card list template, looking here for the edit button, we are going to see that whenever we click on this edit button, we are going to call the edit course method from the courses card list component. This method is going to instantiate the dialog using the Angular Material dialog service that we are receiving here via our constructor. As we can see, the course dialog component is not a direct child component of the courses card list component. This course dialog component is going to exist in a completely separate branch of the Angular component tree. In order to understand the error, let's have a look here at the course dialog component and see that the loading service that we are trying to inject here is not accessible by the course dialog component. And why is that? If we search for usages of the loading service using Command Alt F7, we are going to see that the loading service is being declared here at the level of the application component. So this is the root component of our application that contains our whole user interface. It's here that we are defining an instance of the loading service. This instance of the loading service that we are creating here will only be available to child components of the application root component. And what does that mean exactly? Looking here at the application component, we are going to see that the service is going to be available to any child components that are reachable via the application component template, including any components that we replace here as part of the router outlet. This is going to include, for example, the home component. So that's why we managed to inject here a loading service without getting any error. Also, any other child components of the home component, such as, for example, the courses card list component, is going to be able to receive that same instance of the loading service. However, any other component in our application that is not a direct descendant of the application root component is not going to be able to access this instance of the service. And that is exactly what is happening with our course dialog. The course dialog because it's a dialog, it's not a direct descendant of the application root component, so our dialog does not get access to this instance of the loading service. In order to solve the console error that we were seeing that says that there is no provider for a loading service in our component, what we're going to do is we are going to provide to the course dialog a different instance of the loading service. Let's open here the course dialog and let's give it its own instance of loading service by providing here in the providers property of the component the loading service constructor function. So this is going to allow the Angular dependency injection system to create locally at the level of this component a new instance of loading service that can then be injected here in the constructor of course dialog and also in any other child components of this course dialog. So this instance of loading service would also be available here to any child components that we might add to the course dialog component. In order to make sure that we understand that we are effectively creating two instances of the loading service, let's go ahead and add here some logging in the constructor of this class so that we can confirm in the console when each instance is being created. We're going to add a constructor to this class and we're going to say here that a loading service has been created. And with this logging in place, let's now switch back to a larger window and confirm that indeed we now have here two instances of the loading service. So as we can see, the loading service has been created initially when the application has been reloaded. And now when we click here on the edit course dialog, we are going to notice that we have indeed a second instance of the service that has been created, and we can also see that the dialog is now working as expected, so we no longer get the dependency injection error that we saw before. So now we have an instance of the loading service at the level of the edit course dialog that would allow us to display a loading indicator. But there is only one small problem. If we try to use this service instance in order to communicate with the loading indicator that we had installed at the level of our application root component, this would not work. Let's understand why. Going back here to our program, we can see that this instance of the loading service is accessible only at the level of the course dialog. However, the loading indicator that we want to display to the user is visible here at the level of the application root component. This loading component receives here in its constructor an instance of the loading service. Now the question is, which instance of the loading service do we receive here? Do we receive the instance that is injected at the level of the application root component? So this instance here, defined in the providers property of the application component, or do we receive in our loading indicator the loading service that we have created at the level of the course dialog? As you can imagine, our loading indicator that is present here on the template of the application root component is going to receive the instance of the loading service that is available here on this branch of the Angular component tree. The other loading service in our course dialog is a service that is present in a completely different branch of the component tree, and so our loading component cannot access it. In order to confirm this, we are going to go here to our course dialog, and here, for example, in our constructor, just as an example, we are going to call the loading service and we are going to try to turn on the loading indicator by calling the loading on API. Let's try this out to see if it works. I am going to switch here to a larger window. I'm going to confirm that we have here the first instance of the loading service. And now after clearing the console, let's click here on Edit Course. So as we can see, the new instance of the loading service was created, but we don't see here any loading indicator on the screen. And that's because this instance of the loading service that we are using here inside the dialog is not connected to any loading indicator in this particular branch of the Angular component tree. In order for this instance of the loading service present at the level of the course dialog component to have any effect in our program, we need to connect it to a loading indicator instance. So what we're going to do here is we're going to go to the course dialog component template, and here right below the title we're going to create here a new loading indicator that is going to sit on top of the dialog. Let's remember, our application might have different loading indicators in different components in order to give some feedback to the user about different waiting states of the application. This second instance of the loading indicator that is present here on the template of the course dialog is going to receive in its constructor the loading service that we are defining here on the provider's property of the course dialog component. So right now in our program we have two loading indicators, one at the level of the application and another at the level of the dialog. Each of those loading indicators can be controlled separately by interacting with its own instance of the loading service. Let's see that now the loading on call that we are doing here is going to indeed trigger this loading indicator here on the course dialog component template. We are going to switch now to a larger window, and after the application has been reloaded, I'm going to click here on the edit button. And this time around, we can see here a new loading indicator that sits on top of the edit course dialog component. We can now use this new loading indicator to give some visual feedback to the user while the save operation is ongoing. So going back here to our course dialog component, we are now going to use the loading service in order to create here a new save course observable. This new save course observable is going to contain the observable that we get back from the courses service whenever we call the save course operation. Now we are going to access the loading service, and using the same show loader until completed method that we have seen before in action, we are going to pass it the save course observable. This is going to give us back a new observable with loading indicator capabilities. So whenever the observable gets subscribed to, the loading indicator is going to be turned on, and whenever the observable completes its life cycle, the loading indicator is going to get turned off. Let's not forget to remove this instruction that we added here in our constructor just for debugging purposes. Let's now try this new version of the application. We are going to open the edit course dialog. We are going to do here a couple of changes. Let's say that we are going to change the title of the course. Let's now click here on the save button, and let's pay close attention to the presence of the loading indicator that gets displayed here. Now the dialog gets closed and we are back to the home component. Because our application is still completely stateless at this point in the course, we had to call the server again in order to get back the updated data. So that's why that second loading indicator that we saw on the screen was present. Let's now quickly see this again in action. I'm going to click here on the edit course dialog. Let's change here the title of the course. I'm going to click save. This is the course dialog loading indicator, and this is the application root component loading indicator. As we can see, the Angular providers property here at the level of each component is a very practical way for creating local instances of the service that we want to be accessible only locally at the level of the component and its child components. And with this, we have completed the implementation of our loading indicator functionality. Let's now continue this ongoing section of the course on reactive component interaction. We're going to be talking next about error handling. So we're going to show you how to build an error messages panel here on top of our application that will easily allow us to display errors that might occur at different places of our application. Hello everyone and welcome back. In the next couple of lessons, we're going to be talking about error handling in a reactive application. So we are going to be implementing a very common error messages panel functionality that we're going to be adding here to the top part of our application, right below here, the top menu bar. This will be an error messages panel that is going to be closable, that is going to allow us to display an error message to the user from multiple places in our application. We are going to be able to, for example, display an error message to the user if something goes wrong here in our home component. In a very similar way to the previous case of the loading indicator, the case of model dialogues is a little bit different. So in the case of a model dialog, we want to display the error message to the user here on top of the model dialog so that the user can fix locally here any errors that might be present before closing the dialog. So in order to help us with the implementation of this messages component, we already have here an initial skeleton for our functionality. Here inside the messages folder, we have here a messages component template, which is currently empty. We have here a messages component that currently only implements here the onInit method and has here an onClose empty method. And we also have here a messages component CSS file that contains a little bit of CSS that we're going to be needing in order to display the error messages to the user. As we can see, this is going to be a panel with a red background. Let's now start to put in place our solution for a messages component, and we're going to see how adopting a reactive approach is going to again make it very simple for different parts of the application to interact in a decoupled and transparent way with the error messages panel. Let's start with the messages component template. The messages component is going to be made of a container containing a list of messages. Our container is going to have the CSS class messages container, and inside it we're going to loop through a list of errors. Each error is going to have the CSS class message. Let's use the Angular ng4 directive in order to loop through a list of errors. Let's say that we have here an errors property. In that case, we are going to use the syntax let error of errors in order to loop through our list of errors, and then each of these errors, which is going to be a string, is going to get displayed directly here on the screen using the Angular template interpolation syntax. Our messages container panel is going to be a red background panel that is going to extend here over the whole length of our application, and we're going to have here a small close button. So we are going to be adding here the close button. This is going to be a material icon. The icon that we are going to be displaying is going to be the close icon, which corresponds to a close cross. And we're going to give this icon a CSS class, which is going to be the close class. Whenever the user clicks on this icon, then we're going to be calling the onClose function. This function is responsible for hiding the whole messages container from the user. Now let's see how the onClose functionality is going to get implemented. So initially our component is going to be showing or hiding the messages from the user depending on the value of a show messages flag that we're going to set here in our messages component and that we are going to initialize to false. So initially there are no errors to be shown to the user, so we are going to hide our error messages panel in order to avoid displaying to the user an empty panel. Let's switch back here to our template and let's use the Angular ngIf directive in order to show or hide the messages container depending on the value of the show messages flag. Now whenever we click here on onClose, then we want to hide the panel from the user, so we need to set show messages to false. Now the question is, at which point does this flag turn to true? This flag is going to turn to true if we get some errors from somewhere else in our application that we want to display to the user. Now the question is, how will the rest of the application interact with our messages component in a decoupled way? As we have seen before, in the case of the loading indicator, we can achieve this decoupled component communication in a very simple way by using a shared service with an observable-based API. So that's what we're going to be building in our next lesson. We're going to be building a messages service that is going to allow us to interact in a decoupled way with the messages component.